Today we are Unit 7, Day 3. So let's start off with a warm-up from yesterday. Find the exact value of each of the following. You can either use your unit circle or draw triangles. If you're in more advanced class and you're going to more advanced math, you need to do the drawing the triangles. And also, even on the EOC, you're not going to have the unit circle to actually do all of this with. I'll start out by drawing triangles here and the different things. But here, okay, sine of 3 pi over 4. Okay, pi is 180, so just the line, and I can divide it into fourths. All right, so it's like this. Well, I know when I divide 180 into fourths, it's a 45, 45, 90. And in a 45, 45, 90, when the hypotenuse is 1, each side is square root of 2 over 2. And then the other thing we learned is sine is y. Okay, now the only thing is I'm in the second quadrant, so what's negative? Well, the x is negative, not the y. So here, the answer is just square root of 2 over 2. If you do plug that in into your calculator, you're going to get some type of decimal, and I think it was like 0.7 something. Okay, now cosine of negative 7 pi over 6. And actually, let me go back. I do have my unit circle here. Here, if we're at 3 pi over 4, 3 pi over 4 is right here. If you notice, this is the point, and the y value is square root of 2 over 2. All right, now remember the negatives don't show up on the unit circle, so that's going to be a little harder. But always start out by drawing your x-axis because we know this is pi. All right, I'm going to divide it into 6. Okay, so 6 look like this. All right. Now, if I do this and I count 1, 2, 3, 4, 5, 6, I'm actually going to need one more. So it ends actually right here. That's where negative 7 pi over 6 is. All right. And this is when, and think, when I divide 180 into 6, 180 divided by 6 is going to be 30. So this is like a 30-degree triangle. And remember what's across from 30. Across from 30 would be 1/2. Across from 60, that would be this other side right here, would be square root of 3 over 2. Okay, and then of course your hypotenuse is 1. Well, cosine, you can think of it as just as x. Now be careful because what is the x in the second quadrant? Negative. So it's going to be negative square root of 3 over 2. All right. You may memorize that point right there. Here, anytime we basically divide by 6, you start out with square root of 3 over 2, and then 1/2, and then the x is negative. So you may memorize that that's the point, and we all do it in different ways. Okay. Okay. Now, because there is no negative here, it is a little bit harder to figure out where negative 7 pi over 6 is, but you could look at it this way. Here, 7 pi over 6 is like half a circle and a little more. Okay, so if I go the other way, if I go clockwise, half a circle, a little more, and lands you right here where the 5 pi over 6 is. So that's another way to look at it when you have the negatives. All right, and you see that point right there. And of course, the sine or the y x value was negative square root of 3 over 2. Okay, sine of pi over 2. Well, if I know pi is here, that's just telling me half a pi lands right here. Well, this lands on the axis. Okay, and so that point, remember the radius is 1. So here the x value is 0, and then the y value is 1. And sine, we're talking about is y. So the y value is 1, and there you go. Now, if you do type out sine of pi over 2, you do get 1 on your calculator. Okay, and right here, cosine of 7 pi over 3. So again, if you're drawing this out, put pi into thirds. Okay, we're going to put this into thirds. Start here, count around 7. 1, 2, 3, 4, 5, 6. Oh, we actually land right here. And this is the same thing as pi over 3. Okay, well, when we divide into thirds, that gives me 60. I know 6 across from 60 square root of 3 over 2. Across this other side is going to be 1/2. The hypotenuse is 1. And cosine is the x value. So the x value is this one running along with the x-axis, and that's 1/2. All right. Or just memorize anytime you have 60, 1/2 comes first, square root of 3 over 2. And I don't have to worry about anything being negative in the first quadrant right there. So we all do it different ways. Don't forget that when you have Desmos, that you can, let me get this cleared off. You can change it. Doesn't give you everything, but you can change this so it's a 0 right here. And then you can toggle between, and you can see it right here. You can toggle between degrees and radians. So radian measure, now obviously, again, we don't see 7 pi over 3, so you got to figure out where that is. But we do see pi over 2 from number 3 right here, that you can see it landed on the axis. The problem is you do have to know the different points and so forth. Okay, so just be careful about that. All right, let's look at number 3. And these two come out of the workbook. It was just easier if I just pasted it on here. So a wheel has a radius of 1 foot, and it's actually documented on there. Okay, after the wheel has traveled a certain distance in the counterclockwise direction, so opposite of a clock, goes this way, the point P has returned to its original position. How many feet could the wheel have traveled? Okay, well here, feet it travels, we're talking about arc length. Okay, now here you can do arc length 2 different ways. We have learned it theta over 360, 2 pi r, and we have learned that it's the radius times the radians. Okay, so I want you to think about this for a second. All right, sorry, hold on. There we go, we're back. All right, sorry, a student walked in for a second. All right. Okay, so we're back to arc length. So we have this one that you would use for degrees, and then you would have this one you would use for radians. Now it just kind of depends on what it is. But do you see how, I mean, it is in pi, but radius times radians is the easiest. And think about it. You're going here and you're returning. All right, how many radians is the whole circle? 2 pi. Okay, so here the radius is 1, the radians is 2 pi. Okay, so the answer comes out to be 2 pi. Now we can still get the answer here because what's the degree? If I go all the way around, the degrees is 360. Okay, 2 pi and the radius is 1. So here these make 1, so they go away, they divide out, and we still get 2 pi either way that you want to do it. Again, for the EOC, you're going to have to know your formulas. So make sure you know your formulas of the arc length right here. And number 9, the x-coordinate of a point P on the unit circle is 0. If point P is the result of rotating the point 1, 0. Okay, so hold on, let's start there. The point 1, 0 here. So we're rotating this by theta, radians counterclockwise about the origin. What angle could theta represent? Well, here it's telling me that the x-coordinate is 0. Well, where is the x-coordinate? 0. X-coordinate is 0, say here. Okay, well, where have I traveled? I've traveled pi over 2. If you remember the unit circle, that's just half a pi. Now, it could also land down here. Okay, so it could land all the way down here. And so like here, this would be the point 0, 1. This would be the point 0, negative 1, the x-coordinate 0. So here, to go here, think this is a pi plus another half. So think pi plus another half pi. All right, you end up with, this is 3 pi over 2. So you're looking for one of these. Now, the thing is, you would select all that apply. So pi over 2 was an answer, and 3 pi over 2 is an answer. Now, you can kind of eliminate it as well. So like here, this is 0. Okay, that's not 1. Pi lands right here. Okay, so that's the point right here would be negative 1, 0. Y is 0, not x. All right, and 2 pi lands back where you are at the point 1, 0. Again, y is 0, not the x, so it's not 2 pi. All right, so make sure you understand that, and that's still kind of keeping up with unit circle and so forth. Again, you can use the unit circle or the circle that you see on Desmos as well. All right, so let's get started with our lesson today. We are talking, and if you look at the top, it says periodic data in sine and cosine graphs. All right, so periodic function. A periodic function goes something like this. All right, and you're going to see how does this fall into play with what we've been talking about so far in this unit. Okay, a periodic function, it's a function that repeats a cycle, all right, hold on, we're going to fill these in, that repeats a cycle or a pattern, either way you want to put it, of y values at regular intervals. So think about that circle. We keep going around and then it keeps repeating itself. All right. So a cycle is one complete pattern. And the period of one cycle, okay, the period is basically one, and I'm trying to think what I wanted to put there. I guess like a complete, and this isn't going to make any sense, complete of one cycle. It's just basically, it's just one cycle drawn out. Okay. And you're going to see it here, so it'll make more sense. All right. So name one cycle two different ways and then determine the period of the function. Okay. So this right here, we want to name one cycle in two different ways. You may want a highlighter here, and let me grab one. Okay, one cycle is one complete. And so we're going to name basically the interval of one cycle. Okay, so we can do it different ways. You may pick it now, you may pick it like right here from -2 to, all right, and it's basically one complete pattern. And I'll add that of one cycle. Okay, so here it's down here and then it goes up. Okay. And do you notice it then starts to repeat? So one cycle runs from -2. So the interval, I'm going to write this, runs from -2 to 1. All right. Now, you may not have chosen that. You may have said, well, one complete cycle may run from the top of this to the top of that. All right, so let's look at that. Look at the x value. So that one would run from -3 to 0. All right, no matter what is it, no matter what this is, the period, so we named the cycle in two different ways. We can actually do more. Okay, we're going to determine the period. And I think I finally figured out what this word should be. It should be length. Is the length of one cycle. All right, so think about this right here, from -2 to 1 and from -3 to 0. What is the length of one of those cycles? Well, to go from -2 to +1, it's 1, 2, 3. And same thing from -3 to 0, 1, 2, 3. It has a length of 3. So that cycle has a length of 3, and that's what we call the period. All right. Now, let's determine this one right here. Okay. Again, you start somewhere. I kind of like to go from max to max or min to min. If you see that on here. So like here's a max right there to max. All right. And then it starts to repeat. And so if you notice, that interval goes from the value of -3 to 1. Okay. I can also name it in a different way. So let's see. Some of you may say, now you don't have to do max to max or min to min. You could even do this right here, like -2 to 2. That's another way to do it. All right. So -2 to 2. No matter which one you choose, what's the distance from -3 to 1 or -2 to 2? All right, well, that distance is a distance of 4. So that is going to be our period. You can even also always just choose, and let me get a different color. You can even sometimes start at always start at 0 and go this way. And you can see that it ends here. Sometimes that gets a little confusing because here it started at the x-axis and some people want to stop it at 2, but really you need to go all the way to 4 because it's above the x-axis, below, and then it goes above. And so then I start to repeat after 4. All right. And so when I say 0 to 4, you can tell what the distance is from 0 to 4. 1, 2, 3, 4. All right. So try this next one on your own, if you would like. Pause it and then come back. All right. So right here, if I do it, I might do from -4 to 0. Could be 1. All right. I could also do like 0 to +4. All right. All right, I could even go like min to min. So like this min, I could do like -2 to 2. All right, so I have it -2 to 2. But basically, what is the period of it? All right, well, basically, the distance between all of these different intervals is 4. So that is our period. Okay, the length of one cycle. All right, period is length of one cycle. And one cycle is one complete pattern. All right. Now, coming down here, determine whether each function is or is not periodic. If it is, find the period. So let's look at this. Now, it's got to go to the same max and the same min each time. Okay, so look at number 4. Does that go to the same max and same min? No. Okay, so not periodic. If you want to make a note, it needs same max and min. All right, and here we don't even have that here. Now here, I do have the same max and min, but I want you to look at this for a second. Okay. Now, when I start to look at this, let's highlight one cycle. Okay, so one cycle appears to be this right here. Okay, so it looks like it goes from like, now I want you to notice each box is worth a half, so be very careful here. So this would be like a half and a half, make 1, and then so another half would make 1.5 and then a little bit. Okay, well, look right here. Here would be another like cycle of it. Okay, but do you notice this is more boxes? 1, 2, 3, and then some. So it looks like it's actually getting wider. So this one is not periodic again. The intervals need same distance. Okay, so since we're saying it's not periodic, then we can't find what the period is. All right, and this one. Now, this one really does look like it. So let's look at it. All right, here, when I go from here to here, okay, and then it starts over again. Looks like it has the same max and min. So let's look. Do you see how that goes from -5 right here to 0? Okay, so this length has a length of 5. All right, now let's look at this one. Okay, we come up. All right, now wait a minute right here. Do you see how this comes up? Okay, yes, it goes to the same height, but do you see how this part right here isn't as steep as that part right here? This is actually steeper. Okay, although it looks like at first it is periodic, this one is not necessarily periodic. Okay, because this period is not the same thing as that, or that cycle right there is not the same thing as that. So here it is not periodic. Sometimes it is hard to see these things. So you really have to dive in and you got to look at it. All right, a lot, especially when they have the same max and mins. Okay, now I've got some other words right here, and we're going to use this, and I'll use some of these up here to talk about it. All right, I'm going to start with midline first, and then I'm going to go to amplitude. A midline is a line that runs horizontally in the middle of the graph. Okay, well, what do I mean by that? Okay, so you're going to have, say, sometimes your periodic function is going to look like this. Okay, now pretend that's the same maximum. All right, you're going to have a line that runs through the middle of this graph. In this case, it could be like your x-axis. All right, you may also have a graph that might look like this, but it may be up here. Let's see, like that, and your midline will run right here. So that's going to be your midline. And we're going to say that this is some, and we'll say this like y equals, I'll give a k value. All right. So in this case, that would be like y equals 0. But here we don't know what that value is since I didn't put any numbers on it. But it's some y equals k value. It's always going to be y equals is what the line is. Now, the amplitude. Okay, when we talk about the amplitude, and you'll see why I did it for a second, because I like to use the midline here. The amplitude is the distance from the midline to the max or to the min. So an amplitude is always positive. Okay, amplitude is always positive. So that distance, like right here, this would be the distance here, whatever that distance is. Or, so that would, I'll call it A. Same thing here. This would be A right here, the distance from your midline to your min. Okay, and then the same thing here. Like here's my midline. This would be our amplitude whenever we count it. And you'll see us do it in a second. Or you can go from your midline to your min. All right, that could also be your amplitude or your A value. All right, so here we go. We're going to go to another page right quick. All right, so still talking about periodic data, and you still see some of the same graphs. So find the amplitude. I'm actually going to say in there, let's also find the midline as well. All right, because a lot of times I actually find that midline first. Go highlight it. All right, so here, if I highlight the midline, so the midline's right there in the middle. And since it's the x-axis, the midline is going to be y equals 0. Okay, now what is the distance from our midline to our max right there? Well, the distance is 1. Well, guess what? That's our amplitude. Okay, it is also 1. All right. You can also do the midline to the min as well, and you'll see that is 1 as well. Okay, and if it's not, then you didn't get the midline. All right, so let's get the midline here. Let's see if we can get in the middle of this. All right, it goes from here, and notice I got 1, 2, 3, 4 blocks. So I'm gonna have 2 blocks on that side, 2 blocks on that side. So my midline is going to be right in here. Okay, well, notice, just be careful. That is a 2 right there if you can't see it. So that's 1 and then that's 2. So that must be at y equals 1. Okay, that's our midline right there. All right, now what is our amplitude? So what is the distance from our max to our midline? It's a distance of 2. So midline is y equals 1 and our amplitude is 2. All right, now pause it to see if you can do this one. This one can get a little tricky, so because be careful. This is a 4 right here. That means this is 2. And then that's going to be -2. Now be careful because this is 1. So that's a half. That's 1, 1.52. So just kind of be careful on that. All right. So when I'm doing the midline, it appears the midline runs right there. Actually, did I do that right? No, I didn't, because look, and some of you may have done the same thing. All right, now I can't go backwards because this is blue. I'll do it in a different color. Do you see how that's just 1 and now that's 2? All right, so that's not it. There's a total of like 3 blocks. So half of 3 is 1.5. That block is actually right here. Okay, now remember, so I'm ignoring the blue line. I'm looking at the orange line. All right, so I'll just kind of mark the blue line out. Remember, these are boxes on our y-axis are in 2s. So that's -2. So really, where is that hitting at? Y equals -1 would be our midline. All right. And again, like right here, this is 1.5 boxes, but when they count for 2 each, that's going to be 1 and then 2, 3. So our amplitude is 3 here. So be careful if they change the axes. You got to always pay attention to that. And your x and y axis may not be the same thing either. All right. Now, how do sine and cosine functions play into this? All right, now let's think about the unit circle for a second. And if you need to grab the unit circle out, you can. I'm going to do some things by memory. All right, so here we're going to draw this out. And I'm going to draw this out without a calculator first. Then I will show you in the calculator. Now, one of the things I want you to notice is all of these are radians as well. We really think mostly in radians since we've introduced it. Okay, so f of theta, notice theta is sine theta, so sine of 0, all right? Well, when I think of unit circle, 0, all right, is right here. Okay, that's the point 0, 1, and sine is y. I'm sorry, I lied, it's 1, 0. Okay, so sine, so y, and that's 0. Okay, pi over 2, sine of pi over 2 is here. Well, that's the point 0, 1. Well, y is 1 here. Okay, sine of pi. And notice I did this really nicely. Pi is right here. So that's the point. -1, 0. What's the y value? 0. Okay, 3 pi over 2 lands right here, and that's the point 0, -1. All right, so when I do the sine of 3 pi over 2, all right, the y value is -1. All right, and then when I go back to 2 pi, that goes back to this point right here. So the sine of 2 pi is 1. Okay, and I'm sorry, 0, sorry, because it's the y value. I can plug all those in and figure out what the value is. Just make sure you're in radians if you're in desmos. Okay, so here we go. Let's actually graph this right here. Okay, now, whenever I graph these, and you're going to get used to graphing them, all right, notice we're going to have 0. Okay, in this case, pi over 2. All right, pi, 3 pi over 2, and 2 pi. I'm only going to do one cycle. Did you see how this went here and then it went back to 0? And then guess what? It's going to repeat that cycle. All right, just like we were just talking about, there's a pattern and it repeats. All right, so here we go. The sine of 0 is at 0. And I want you to notice the max here is at 1 and the min is at -1. So I'll just do that. And here at 0, it's at 0. All right, at pi over 2, it's at 1, so it went up. At pi, it goes back to 0. And then here, it goes back down to -1. All right, and then at 2 pi, it goes to 0. And then we're going to start over. So we can connect these, make it like a curve, like you've been seeing today. All right, and I just did one complete cycle. So let's look at this. Let's talk about some of the vocabulary words that we've been talking about. All right, we've seen the word period. The period is the length of one cycle. So what is the length of one cycle before it started to repeat? Do you see from 0 to 2 pi? So the length of one cycle here is 2 pi. All right, now the midline, okay, midline. Well, do you notice that the middle line is going to be right here? So our midline is y equals 0. All right. And then our amplitude is the distance from here to here. Okay, amplitude. All right, so our amplitude, that distance is 1. All right, now let's go verify this all on Desmos right quick. I'm going to make this big. Now, I want the Cartesian coordinate. I don't want this circle. So I'm going to hit this again. All right. And then I'm going to just type in sine of, and you could put theta or you could put x. It doesn't matter. I'm just going to put x for this case. All right. Now, start looking at this. Now, we don't know exactly where this hits, but it actually kind of, when you're doing these, it does make it nice. A lot of times they do decimals for things, but Desmos, when they do this, especially when you start talking about pi and all of that and 2 pi, sometimes it actually hits. Now, if you notice right here, do you see how it looks like from 0 All right, that is one cycle all the way to 2 pi. All right, so what if I do this? I'm going to zoom in. I'm going to go, I can take this and I can change my settings 0 and I can say 2 pi. So 2, and then if you type in pi. Now, my height is -1 to 1. So if you want to do like -1 to 1, you can. And so we're seeing the same graph that we looked at. Now I'm going to take my fingers and zoom in just a little bit. All right, so look at our top points right here. That was 1. Here's a max. Notice how it does 2 pi, or pi over 2 and 1. We had that. Pi and 0. 3 pi over 2 and -1. And 2 pi right there. All right, those are all the things that we just graphed just a second ago. All right, so let's do the same thing with cosine. All right, now I already have this for cosine, so that's going to make this a little bit easier. Move my picture a little bit. Okay, so here we go. And remember, cosine is x. So at 0, the x value is 1. All right, at pi over 2, the x value is 0. At pi, the x value is -1. At 3 pi over 2, the x value is 0. And then when we get back to 2 pi, we're back here at this point, and it's 1. And we start all over again. So let's draw this out. You're going to notice I'm going to do the same y-axis because it only goes to 1 and -1. All right, and then the same x-axis. All right, here, pi over 2, pi, 3 pi over 2, and 2 pi. I picked out the different thetas for you and radian measures. Okay, so here we go. At 0, it's at 1. Okay, here at pi over 2, it's at 0. Then at pi, it's at -1 down here. At 3 pi over 2, it's at 0. And at 1, it's at 1. So it's doing something like this. Now, again, this is one complete cycle, and then it starts over again. It kind of goes from max to max, if you want to think of it that way. Now, I want you to notice some differences between here. Okay, notice the starting point of sine, and I'm going to come back to this later in tomorrow and even today. Sine starts here at our midline. Here, where is our midline? Where our midline is the same thing here. All right, it's still y equals 0. Here, the sine starts on the midline, but cosine doesn't. You're going to hear me say that later. All right. Now, our amplitude is still, okay, amplitude is still 1. All right. And then our period for this, one complete cycle goes from 0 to 2 pi. So the length is 2 pi. All right. So still be able to pick those out, and you're going to be picking those out throughout. All right. Now, these, and by the way, we can go back to Desmos, and instead of having sine, we can have cosine of x. And look, isn't this the same picture? And then here, I can actually hit these same points, and these are all the points that we actually graphed right there. Some pretty nice points. All right, and you can see one complete cycle goes from 0 to 2 pi. All right, so that's kind of how you can tell. And I'll be using Desmos throughout as we're talking about these graphs. Now, the two up here, the sine theta and cosine theta, those are the most basic forms of sine and cosine, but we can change them up. All right, we can change it up and do like y equals a sine b theta plus k. All right, and we can do y equals a cosine b theta plus k. Now, when you go to math 4 or pre-cal, they're going to add a few other things in there, but I'm just going to leave it like this for math 3. We've got these a's, b's, and k's in here. Okay, now what is the amplitude? The amplitude is going to be this a value, but I'm going to put absolute value around it because that a could be negative, and we'll talk about what does it mean when that a is negative. All right, now what does the b do for us? Well, b is the number of cycles between 0 and 2 pi. Okay, so we'll be talking about that. And we have a formula for the period. The formula is 2 pi divided by b. So if b is the number of cycles between 0 and 2 pi, then 2 pi over b is the actual period of it. Now, I added this k in, and you don't see midline, but I'm going to add it in. Midline is y equals k. All right. Now, if we don't see anything added or subtracted out there, like here in the up here, and when we did cut cosine and sine, we didn't see anything added or subtracted, you're going to see that midline is going to be y equals 0. All right, so here we go. Let's see if we can give some different information on this. And I'm going to graph some of these so that you can see it as well. So here, this 0.4 means our amplitude is 0.4. Okay, now B is, so there's going to be 5 cycles from 0 to 2 pi. That's what that B means. So for our period, what it means is that it's 2 pi over 5. All right. So let's go graph this. And this is, you can get some of this stuff just by looking at the graph as well. So if I put 0.4 sine of, put 5x in parentheses, please. Now, as I zoom in right here, I can see that one cycle runs from here to here. Now, I want you to look. The other thing is I'm going to hit the max or min right here. Do you see the distance from this 0 to here is 0.4? The height is 0.4. Okay, the other thing is one complete cycle ran from 0 to 2 pi over 5. Did you see our period was 2 pi over 5? All right, so let's go back. Okay, can we pick out the amplitude? All right, and the period here. All right, and you can pause the video and you do it yourself. All right, now here, the amplitude is 3 because it's the number out in front. If that number is negative, just take the positive of it, okay? And then here, it's going to be 2 pi divided by a half. All right, now if you're like, how the heck do I do that? If you don't know how to do that by hand, just take the number, don't take pi, just take 2 and divide it by, put 1/2 in parentheses, otherwise you get the wrong number. This is 4 pi. All right, now we could do it on our own, or we can go to our calculator. Okay, so here, if I type it in, 3 sine of 1/2 and then x. All right, so when I look at it, so one complete cycle goes from here to here. So notice that's 4 pi. Wasn't that our period? Okay, and then here I can see my midline, and if you want to, is y equals 0. You can plug that in. And the distance from this line to here, okay, as long as it's 0, it's just whatever this number is for my y value. So it's 3, which is what we just did. But again, guys, this is your amplitude right there. That's out in front of sine or cosine. All right, going back. Here we go. What is our amplitude? Our amplitude is 1.5. Okay, what is our period? Remember the formula, 2 pi over b, so 2 pi over 2. Now, if there's nothing in front of theta, our b value is 1. All right, and it'd be 2 pi over 1. Here, the 2's cancel, and so the length of our period is just pi. All right, I'm not going to check that on the calculator, but I will check this one. Okay, so amplitude. All right, if you said 3, you are correct. The period. Now, this one's going to be a little wonky, okay? So we're going to say 2 pi over, this time our b value has a pi in it, pi over 2. Okay, now if you are trying to do this by hand, think 2 pi, this is divided by pi over 2. And when you have fractions, think of that as 2 over 1. You keep this one the same, you change it to multiplication, and you flip this one. Now, do you notice how the pi's are going to cancel out right there? Whoops, nope, you don't. There you go. The pi's cancel out right here. Okay, and you're left with 2 times 2, which is 4. So our period is actually 4 here. Okay, now if you're like, that is really, really complicated. All right, then go to Desmos. All right, let's type it out. Okay, 3 cosine, all right, pi divided by 2, and then they have theta here. I'm just going to put x. All right, now it appears that one cycle goes from here all the way to here, max to max. All right, do you see how that length of that cycle is from 0 to 4? So it's just a length of 4. So if you start at 0, you can always kind of see what it is. All right, so it's 4 right there. Now, what is our amplitude? Well, here, again, it looks like our midline is y equals 0. And again, it is y equals 0 because there's nothing added or subtracted right out in here. Okay, so really, if we just take one of the maxes, we see that it is 3. But again, it's just whatever number's out there. Just make it positive if it's negative. All right, so there we go. Now, number 14 and 15, we're going to draw this right here. Now, draw a sine curve. All right, so watch how I draw this out. I'm going to draw that right there. Now, it doesn't say anything about midline on here, so I'm just going to assume my midline is y equals 0. All right, it's got a period of 8. Now, all of our graphs, I like to put 4 things right here. All right, it's got a period of 8. We're just drawing one cycle. All right, now I like to put 4 tick marks. Those are going to be very important. So 8 divided by 4 gives me 2 pi. All right, so each of these are a length of 2 pi. You can even start out by saying 8 pi, what's half of 8 pi? It's 4 pi. What's half of that? That's 2 pi. And really, I'm just adding 2 pi each time. So that's 6 pi. All right, now the amplitude is 0.2. That means from my midline, in this case it's y equals 0, it's going to go up to 0.2, but it can go down to negative 0.2. And now remember when I said something about sine, I said sine starts on the midline. So if my midline is y equals 0, then right here on the y-axis, this is going to start at y equals 0. Now, this tells me my a value is positive. As long as my a value is positive, I start and I go in the positive first. And I go up here, then I hit the midline, then I go down here to the min, and then back to the midline. All right, if my a value is negative, I would start below the x-axis. I mean, below the midline, or the x-axis in this case. Okay, so there's a graph of that right there. I can also write the equation. Y equals 0.2. They told me it's sine. The only tricky thing is you have to find your b value. Now, remember this. Our period is 2 pi over b. But they told us our period is 8 pi. All right, so think about this for a second. I like to multiply by b. So 2 pi equals 8 pi b, and divide by 8 pi. You're going to see the pi's cancel out. And what is 2 eighths? It's just 1/4. So b equals 1/4. So when I write the equation, 1/4, we'll just put x. And if you want to graph this and verify that that's what it is, you can. All right, so here and see what it looks like. So 0.2 sine of, make sure you put parentheses, 1/4 x. All right, now, obviously it's not that high. If you actually want to do it this way and say, okay, my x-axis, I'm going to go like 0.5, actually negative 0.5, put negatives here, and then 0.5. All right, you can see that one cycle. And you can see that it ends right here at 8 pi. So that period is 8 pi. So I must have done it correctly. And here the height is 0.2. All right, and that's the same graph that I had on my page right here. All right, one last one. Draw a cosine curve. All right, the amplitude is 3. All right, I'm going to say my midline is y equals 0. We'll look at more of this tomorrow. But my amplitude is 3, so I'm going to do 3 and negative 3 right here. Now, start off with 4 tick marks. And so if you take your period and divide by 4, that means each of these is a pi. So then that's 2 pi, 3 pi, 4 pi. Okay, or sometimes you'll see me put 4 pi here, take half, that's 2 pi. Half of that is pi, so then I'm just adding pi each time. It's another way to do it. Now, this is cosine. That meant it doesn't start on the midline. The midline is this thing, the x-axis again. All right, so it starts either at 3 or negative 3. But here's a is positive, so I'm going to start at the positive above it, the midline. And then I can just draw my points. Now I go to the midline, I go to the mid, go to the midline, and go back to the max. Here's my graph. But we're also going to write the equation as well. All right, so it's a cosine. My A is already that, and I know it's positive. Okay, the only tricky part of this is going to be finding the B. That is the hardest part. So remember, 4 pi over B equals the period, which is 4 pi. Okay, multiply by B. Okay, so 4 pi equals 4 pi B, and then notice, I'm going to divide by 4 pi. What's 4 pi divided by 4 pi? It's 1. So our B is 1. You don't have to put the 1, but you can, and then put X. So this is really just 3 cosine X. So here we go. 3 cosine of X. All right, now that's a lot going on there. Again, we can change that. So here our y-axis went from -3 to 3. And really, if you go and look at your graph, it goes from 0 to 4 pi. All right, and did I do that right? No, because wait a minute, if you're like Miss Olin, you were doing stuff wrong. Oh yeah, because the formula is not 4 pi, it's 2 pi over b. Let me go fix that right quick. All right, so here you actually end up with 2 pi. So b does not equal 1. The pi's do cancel, and 2 over 4 is 1/2. So really that needs to be 1/2. I apologize for that. I don't know what happened. So let me go fix that. But you know what? I checked it here and I'm like, oh, I did something wrong. All right, we all can learn from that. Okay, so here we go. Now does that look like it? And it does. And if I zoom in a little bit, I can kind of hit those key points. Here, that max right here. Here, the period ended here, so it's supposed to be 4 pi. The min is 2 pi. Okay, and you see these other points that we graphed as well. All right, so go back, watch this. Remember your unit circle because that comes in handy as well for some of these values. All right, and we'll see you back tomorrow. We're going to add on to this.